So in 2-6, we have done everything but number 2 and 3. But what we've done in 2 and 3, or what we need to start with 2 and 3 is going to help us do the new thing. We're talking about limit notation, but before we do that, we actually have to sketch our graph. So this is the equation that I have in number 2. Before we sketch it, can you remind me how we find all 5 things? What are the 5 things that I want to find when I look at this equation? What's one thing I want to find here? Horizontal asymptote. What do I do for horizontal asymptote? In this case, it's the coefficients. What happens if it's the number the exponent on bottom is bigger? 0. What happens if the exponent on top is bigger? What was it? It's slant. And what do we have to do to find it? Synthetic division. We did 2 of them yesterday. All right, what else? Besides horizontal asymptote, what else do I need to find? Vertical asymptote. How do I find vertical asymptote?
The denominator.
Yes, denominator. Set denominator equal to 0. All right, what else do I need to find? X-intercept. How do I find my x-intercept? Set the numerator equal to 0. And then we also need to do our y-intercept. How do we find our y-intercept?
Like 0.
Plug in 0. And then there's one more thing that I taught you guys better than I taught my other class, but I didn't teach it well earlier yesterday. It was holes. Remember how we find the holes? If something cancels, it's my canceled factors. Okay. So I've got all 5 of our things right here. Why don't you take a second with the equation that we have and figure out what all of those things are. Then we're going to graph them, and then we'll deal with that limit notation off to the side. But you need to get a graph there in order for us to do anything with this. Graph so we can do anything with this. This has to fit in there. Yeah, there's no points to go through for that top C, but you do need some kind of C curve up in this quadrant over here. Before I move on to this kind of new limit notation, are we all okay with vertical asymptote, horizontal asymptote, x-intercept, y-intercept? No holes here. Everyone okay with that? Mm-hmm. Okay, we'll do another one to practice in a second. So if that's still a little shaky, you'll have another one to practice and you'll have some on homework tonight. Okay. The kind of new thing that if you started last night's homework, you might not have figured out is this limit notation. Now, I talked to you about this when we were back in our BFF graphs. Do you remember that a little bit? When you were in Algebra 2, more often we write like as x approaches negative infinity, y approaches, and then you like fill in the blank. Do you remember doing that? This is the exact same thing. Here, down at the bottom is my x. This is what x is approaching. X is approaching positive infinity. And then it's the limit, or it's what's y approaching. F of x is the same thing as y. So if you want to think of f of x as y, you can put a little y on top of that. So my question to you is, what is x, or if x is getting bigger and bigger, what is y doing? As x gets closer and closer to that, what is y doing? And so in this case, we're getting more and more positive. So we're going like towards the off the graph to the right. What is my function? What's my y doing?
Getting smaller.
Getting smaller. What's it getting closer to?
1.
1. Getting close to 1. How do you see that, Joey?
Because, that's the horizontal asymptote.
Good, it starts approaching that asymptote, it's never gonna cross it, it's gonna get closer and closer and closer, so it's rapidly approaching one. What's my Y doing? My X is getting bigger and bigger, they told us that. What's my Y doing? Okay. Same idea, now we're gonna do it for our, now we're gonna do it for negative, infinity. Okay, so now we've got x is approaching negative infinity, so we're gonna come at it from the other side, and we're gonna get closer and closer to out of bounds that way. What is my graph? Now I'm lower, but now I'm going higher. What am I approaching this time? One again. Ooh, that's interesting. That might be something of note. We'll do the other one, and then we'll kind of talk what that means. Okay. Next, I've got this other notation. This is probably new to us. It's x approaches 2, and then it's got that little plus sign up there. That plus sign means from the right. So we're coming from the right-hand side going towards it. And then the negative over here means coming from the left, getting closer and closer to that number. So it's like we're like kind of narrowing in on it. We're approaching it. What is 2? What's that number signify in this equation? Or in this graph? The what? The vertical asymptote. So we're looking at the vertical asymptote and we're looking at both sides of it, okay? So the first one, we're looking at it from the right. So we're starting on the right-hand side and we're going towards the vertical asymptote. What is my graph doing as it gets closer and closer to that vertical asymptote? What's my Y doing? Going up. What number is that?
Oh, infinity.
Infinity. The Y is getting closer and closer to infinity. The X is getting closer and closer to 2, but Y is infinity. I don't know why I wrote 2. And you can write a little plus sign in front of your infinity if you want, or you can just make it infinity. It doesn't matter. Similarly, we're going to go now from 2, but from the left-hand side, so from the opposite side, okay? We're still going to follow our graph. We're still going to look at everything. Now I'm just coming from the left-hand side. So I'm following my graph. What is my Y doing as I get closer and closer to 2? Negative infinity. Okay. Notice when we were approaching the vertical asymptote, either from either direction, we're going either positive infinity or negative infinity. Okay. Let's look at my next one. Let's graph that, and then let's do our limit notation and see if there's any patterns. I'm so sorry. Or anything else we can do. Okay, I'm gonna be quiet. You guys do horizontal and vertical asymptote. We'll come back together. You guys do horizontal and vertical asymptote.
Like, I know how something.
Well, is there a factor on top and bottom here that cancels? No. So on ones that we did yesterday, if you simplified it out like this, if there's a factor on top and bottom, we just cancel. I've got my graph up. Does it look like yours? One good with that so far? Okay, let's do our limit notation. What's my limit of my function as x approaches positive infinity? As x gets bigger and bigger, what is y getting closer and closer to? 2, very good. What about as x approaches negative infinity? What is my graph getting closer and closer to?
2.
2. Huh, do you notice the 2 that we've done that have given us whole numbers? What is that approaching in each of them?
The horizontal.
The horizontal asymptote. In each of them, when we look at end behavior, when we look at negative infinity and positive infinity, that gives us getting closer and closer to the horizontal asymptote. That's always going to be the case. So as we approach negative and positive infinity, we're going to always approach the horizontal asymptote. Okay. Now, kind of like the last one, my next one is talking about as x approaches -2 from the right. What's -2 in this graph? Vertical asymptote. Just like the last one. When we approach the vertical asymptote, kind of think about what we got as our last answers. Let's see if we can do the same thing here. Here's my vertical asymptote. I'm approaching it from the right, so I'm coming from the right-hand side. What is my y doing as I get closer and closer and closer to -2?
Going down.
Going down. So what am I going to write?
2.
Negative infinity. Similarly, what happens when I'm approaching it from the left, going up, which is positive infinity. Good. The hard part here, there's not a lot of work. You're just kind of reading the graph, okay? We're going to flip our paper over. We're going to get into some 2.7 step today. You'll have homework on this, and I hope to give you time to work on it. So if you have questions, you can ask me in a little bit, okay? But go ahead and flip. Come find me at 2.7. All right. If I want to solve this equation, what do I need to do first?
The x by itself.
We'll get x by itself, but I gotta do one more thing before I get x by itself. Nikki? Good, you have a couple of things here. You can make all of the denominators be the same. So they'd all be x. So we multiply by x on top and bottom. We multiply on x on top and bottom and then cancel. I think Ms. Hollis really likes to do that. What another thing you can do? Anybody think they know, or do you want me to tell you? Tell you? I know, you're so excited. Just multiply by whatever the denominators are to everything, and that will cancel them out. It's going to get you the same thing either way, okay? But I'm just going to do one multiplication on the outside. So x times x is x squared. X times 3 over x. The x's cancel, so I just get 3. And then x, the one thing people forget is multiply x times 4, and that gives me 4x. So make sure every single thing gets multiplied. Now, all of these should be quadratic formula or factoring. You shouldn't need any PRRs in here. So make sure to move everything to one side so that you can decide if I need to factor or quadratic formula. X squared minus 4x plus 3. Is that factor? Yeah. What does it factor to? X minus 3. X minus 1. So x equals what?
1 and 3.
Good, 1 and 3. Okay, now, when you guys were in Algebra 2, did you guys talk about extraneous solutions? Does the word extraneous solutions mean anything? Okay. Does anyone remember what extraneous solutions means? Okay, you're like, I heard it, but I don't remember what it means, right? Extraneous solution is a solution that you find, but that doesn't work in your equation, okay? Would both 3 and 1 work here? If I plugged 3 in for my x, that would give us 3 plus 3 over 3. What is 3 over 3? 1. What's 3 plus 3? 3 plus 1? 4. Does that work? Perfect. What if I plugged 1 in? 1 plus 3 over 1. That would also work. Okay. You are not going to always plug in. All I care about is what does not work. And what would x have to be to not work here?
0.
0. Why, Joey?
Because you can't, stuff like this.
You can't have zero in the denominator. Good, so as long as my answer does not make my denominator equal zero, it's okay. So we always need to check. It doesn't necessarily mean plugging back in and solving. It just means I need to physically go back and look, will this make my denominator equal zero? It won't, so these answers, both of them are good. Everybody okay with that? Okay, let's go to the next one. What should I multiply by everything over here? X minus 4, do it. I like to be careful with my stuff, but as long as you get to this point, then you're good. We're all good. Can I factor this one? No, so what do I do? Quadratic, good. I'm gonna do it, but I'm gonna be quiet because I think you guys know how to do it too. You guys good? And this is why I don't want you to plug in. I don't want to deal with the messiness of plugging this in, but I'm going to tell you that it's going to be fine because it doesn't make the denominator equal zero. Okay. All right, let's move on. Let's look at the next one. Now this one, before I do anything, I'm going to ask that we factor out anything big before I start multiplying, okay? So x minus 1 is as basic as it gets. X minus 3 is as basic as it gets. What about this? Can I break that down?
Yeah.
Yeah, to be what?
Minus
Good, x minus 3, x minus 1. Why was it helpful that we broke that down?
right?
Now I already know that all of them have kind of the same base of the denominator. I'm only going to multiply by x minus 1 and x minus 3. If it did not break down to that, I'd also have to multiply by this nonsense, which I don't want to do. I don't want to also multiply by x squared minus 4x plus 3. I only want to keep it as simple as possible. Also, now it's going to be super easy to cancel out when I go through to do it. So the x minus 1s cancel. So I get 2x times x minus 3. And the next one's my x minus 3's cancel. So I just get 1 times x minus 1. And in the last one, all of them cancel. I'm just left with 2. Everybody okay so far? Distribute. And I am going to bring everything to one side because I warned you that it should all factor or quadratic formula. And so you have to bring everything over in order to do both of those things. Combine any like terms. And get down to here. Now, I don't know where we are with factoring, but I believe that that's factorable. I know that you can also quadratic formulate it, but it gets very messy sometimes. So I want you to go ahead and try and just factor it right here off the jump. You guys factor the same as me?
Yeah.
Do you guys solve the same as me? Nikki?
You know, what you say.
The first sign goes with the insides. Are both of those answers correct? Do both of them work?
No. No.
What does not work?
Three.
Why?
Because there's X minus three as well.
Good, because there's x minus 3, so if we plugged in 3, 3 minus 3 would be 0. So I am just gonna cross out 3 and I'm gonna write extraneous solution. I need you to check. You're welcome to erase it and only have -1/2. But I like to show that like I solved it, I factored it, I did all the right steps, it just didn't work out, and that's just the answer that I checked and I found as the extraneous solution. Okay, everybody good with that? All right, I've got another one like that. Do you think you can try that without me?
Yeah.
Okay, try it without me. I'll join you in a second.
The third one.
I prefer not to. Mhm. You guys get what I got?
Is 0 extraneous?
Good. Is 0 extraneous?
You can't divide by 0.
Can't divide by 0.
So neither of them work.
Is -2 extraneous?
Yep.
What happens if nothing there is an answer? Do you know what we write?
No
solution.
No solution.
Well,
You can write both of yours and write extraneous solutions, so I know, but at the end of the day, there's no solutions here. Okay. All right, when you're done with that, flip your paper over. I just got 2 more word problems to do. These are what we call work word problems. We're getting some work done. And it takes somebody a certain amount of time, and it takes another person a different amount of time. And then together it takes them a totally different amount of time. Okay, so these are called work problems. 5 and 6 are the same type of problem. Okay. Number 5 says Jessica can finish painting a room in 5 hours. It takes Brenda 6 hours. How long will it take them together? Okay. I like to think about it in terms of fractions. I go 1 over alone plus 1 over alone equals 1 over together. These fractions are essentially like what percentage of the room they can get done or what percentage of the work they can get done in an hour. So if it takes Brenda 5 hours, then in 1 hour, she's done a fifth of the work. You guys okay with that? What about Brenda? It takes her how many hours? 6 hours. So 1/6 is how long is how much she gets done in 1 hour. And then do we know do we know how many hours it takes them if they do it together? We don't know that. Nope, we're not gonna add them together, or else this would be a really short problem.
X.
We're gonna say X. We're gonna say X.
Oh, and then. Find common.
Yeah, this is just like what we did before. You can find common denominators, you can cancel out by multiplying by the denominator. So what should I multiply by?
30.
Good. You can multiply by 30x, or you can even break it apart and say, okay, I gotta multiply by 5 and by 6 and by x. That's the same thing, but since it's like broken apart, it sometimes makes it a little bit easier to factor. However you want to think about it doesn't really matter to me. But now I'm going to do that. I'm going to start multiplying everything by that and simplifying out. So the 5s are going to cancel. So I get 30x. Or no, sorry, I get 6x. The next one, my 6 is going to cancel. So I get 5x. And the last one, the x is going to cancel. So I get equals 30. And then we can solve that. Add them up. Equal 30. Divide. I think that equals 2.72. I think that's what I got in my last class. Which actually makes sense that it takes them a shorter amount of time, because if 2 people are doing the work that one person's doing, it should take them a little bit shorter time. Okay. Let's do the next one. It's the same idea. There's just an extra added component. A drain is left open as the pool is filling. Hose X can fill it in 10 hours and hose Y can fill it in 4 hours. If both hoses are running and the drain is open, it takes 15 hours to fill the pool. How long does it take for the drain to empty the pool once it's full?
The water staying on.
The water is staying on, both hoses are running, and the drain is open. It takes 15 hours.
Yeah, I'm saying like after it's full, are they still running?
Oh, no, I don't think so. I think it's now once I fill it and then I pull the drain out. If the drain by itself was doing the work, how long would it take to empty the pool? Okay. So let's think about all the things I have going on. Okay. What's one thing that's currently going on?
The pool's full.
The pool is filling by what's one hose that's filling it? 1/10. Good.
Plus 1/.
Plus 1/4. Good. So I've got 2 hoses filling this pool. In addition to that, what else is going on?
You're subtracting.
Good. The drain is open, which means I'm subtracting. I'm losing water. How much am I losing? 1 over, no?
Or-
Oh, X.
X.
Yeah.
Oh.
And then it equals 1/15.
I just did the same thing.
Alright, let me finish this up. When you guys multiplied, what did you multiply by? Is anyone working ahead of me? Sorry, I got distracted.
10, 4, 15, and X.
Good, you can definitely multiply by 10, 4, 15, and X. You also can think about those few smaller numbers. I was thinking last class, I was like, okay, I know 4 has 2, so I'm gonna need to do that. But 10 and 15 both have a 5, so I'll just multiply by a 5. And then I'll multiply by a 3 to get rid of the 3 and the 15. And that's actually enough. That's kind of my what is that, least common multiple that goes into all of those.
Yeah.
So if I cancel out the 10, that makes this go to 2, and then that cancels, so I'm left with 6x. And then when I cancel the 4, it's an easy cancel, so that's 15x. And then when I cancel the x, it's 4 times 5 times 3, which is 60. And then when I get rid of the 15, it's just 4x. And I solved it all the way down, and it looks like I got 3.5. Is that what you guys got?
Yeah.
Either way? Okay, perfect. Yeah, that's what I got here. We could do more word problems, but I'm gonna stop so you guys have a little bit of time to work on homework. You have 2-6 due next class because we haven't finished 2-7. We'll finish this and start 2-8 next class.